Right, okay, so let's get going. Hello, everyone. I would say good to see you again, but unfortunately, I'm not able to see all of you. But yeah, nevertheless, welcome back to our third event in this Ahfap online series. As usual, just a little bit of housekeeping for those of you who haven't joined before and for whom it is the first session. As the audience, you might have noticed that you are all on mute and your video isn't turned off. It's just kind of allow us to provide the best experience as possible and also just kind of allow the internet to cope with what we're doing. If you do want to ask questions, we have two ways of doing that. We have the chat. So at the bottom of your screen, you'll have a chat button that you can press. This way you can ask questions, you can chat to the rest of the audience, or there is also a Q&A button. If it doesn't matter where you post it, I'll be monitoring both. But the way we're doing it is that Eric, Henny and Carola will be presenting first, and then we'll be allowing questions at the end of their presentation. But obviously, if you've got a question kind of that you just want to write down to make sure you've asked it, feel free to write it in either the chat or the Q&A. But as I said, we'll only be answering them at the end of their presentation. Yeah, it would be good if you could make sure that you have your first name and your surname in there. Just, you know, it just makes it a bit more personal rather than saying K98 has asked certain questions. It's just nice to actually know who's asked the question. And I think that is it in terms of housekeeping from my end. So yeah, that leaves me with introducing today's speakers. We've got Eric Kirchner, who's Senior Color Scientist at AkzoNobel. We have Carola van Wyk, who's a staff photographer at the Rijksmuseum. I'm sure lots of you already know her from the presentation she's done before at Ahfap. And the same goes for Henny van Beek, who is also a staff photographer at the Rijksmuseum. And the three of them will be talking about exploring the limits of color accuracy and best practice in photography. Eric, I believe you first, if you want to go ahead and share your screen.
Good afternoon, everybody. Welcome indeed to my presentation. Or actually, I should say welcome to our presentation, because as Kira already mentioned, this contribution will be part of a series of three. And Carola van Wyk and Henny van Beek, who both are part of the photography staff of the Rijksmuseum, will give the next two presentations. Now, my name indeed is Eric Kirchner. I work for a paint company, AkzoNobel. Maybe you think, why a paint company? We'll come to that later on. But as a senior color scientist in this project, I work together with the specialist Tamer Koster from AkzoNobel, and of course with Henny and Carola from the Rijksmuseum. And in these three presentations, we will explore the limits of color accuracy in museum photography. In this first session, I will go deeper into the more theoretical parts of this, in the camera profiling with the color checker chart. And Carola and Henny will then continue with discussing the practicalities of camera profiling, taking high resolution photographs, and also about the recently developed image performance tool. Right. So the presentation consists of 5 parts. First, I would like to address the question, well, why technical photographers would need to bother themselves with very strict guidelines on color accuracy, and why does it matter, and how strict are we talking about. Then I will discuss the role of black colors in this whole process, and in the color deviations that we find when building a camera profile. And to investigate the origin of the color deviations, we first look into instrumental errors, and then into the color target. And finally, I will end up with some conclusions, trying to make them as practical as possible. To illustrate the problems that we want to focus on here, this slide shows a fragment of the Nicolaas Maas painting, Old Woman Saying Grace. And actually, Henny and Carola already showed this same slide in last year's conference, when investigating 3 different software tools to create camera profiles. In each case, the profiles were optimized using Delta E 2000. We'll come back to that as well. And this slide then actually shows the optimized images. So even though we are now looking at it under on an uncalibrated display, this example shows that the 3 camera profiles are apparently not identical, resulting in 3 slightly different photographs. For example, the red area looks less saturated in the image on the right, and also in the dark areas in this image we find differences, although, for example, on my particular display that I have here in my room, this is hard to recognize. Apparently, color differences may result when using these 3 different pieces of software, and probably this is due to certain settings in the software, maybe different optimization algorithms, etc., etc. There can be many reasons for this. But for museum photography in general, it is important to be very critical on color accuracy. For example, in high-resolution photography. For example, if you have a large painting like the Night Watch that is shown in this example, then a high-resolution photograph is typically captured by creating a large number of sub-images. And this process may take days or weeks even to complete. The color accuracy between the sub-images needs to be very consistent, and that's why there is a color target that you can see here on the right-hand side of the image, the photograph. And the camera profile is then optimized for this particular setup, including the lighting. And then it is also verified repeatedly during the full photography campaign. And afterwards then, all sub-images are then stitched together to create a full high-resolution image. This is only successful if the colors are consistent between sub-images. And that's one reason why strict guidelines on color accuracy of camera profiles is very important. Actually, there are more applications for high color accuracy. For monitoring color changes in paintings caused by yellowing or by color fading. And this is only possible if the color reproduction can be made as consistent as possible over time, even during a time of years. And another application is to enable detailed comparisons of a painting, say before and after a conservation campaign, or between paintings that are located at different geographical locations, like different museums worldwide. So, since color accuracy is so important for technical photography, standard procedures and international guidelines have been developed over the years. And they cover many more aspects than just color, but here, we only focus on color here. Now, there are basically 2 internationally accepted guidelines at this moment. I take the most strict versions of those guidelines here. According to the FAGI guidelines, the average color accuracy needs to be smaller than a CIE Delta E 2000 of 2, whereas according to the Metamorphose guidelines, the average Delta E 9076 needs to be smaller than 4, and the maximum needs to be smaller than 10. Now, I would not like to go into much detail about these expressions, the CIE Delta E 2000 and the Delta E 9076, but the bottom line of this is there are quantitative measures for the average and for the maximum color deviations. And I think most people or everybody in this conference who works with these guidelines will probably agree that generally it is very difficult, very hard to meet these tolerances. They are very strict, and also earlier publications have shown that it is tough to meet these criteria. So to show you where these color deviations apply, I will briefly go through the standard process of camera profiling. So in the first 2 steps, we place a color checker SG chart from X-Rite or an equivalent color target on a mid-gray background. And using the white patches on the chart, we make sure that the lights are positioned correctly, that lighting is uniform, and we check also exposure time to avoid overexposure. It's also what you see here, the white patches on the edge of the color checker chart. In step 3 of the process, we use the 12 neutral colors in the center of the chart, and the camera profile is optimized in such a way that for the neutral patches, the correct lightness values L are reproduced. So lightness values L. But what are correct lightness values? Now, the supplier of the chart, in this case X-Rite, provides a list of so-called reference data. They contain lightness values L, A, and B values for all the 140 color patches of the chart. These values have been measured by X-Rite using a spectrophotometer. And if the camera profile reproduces the lightness values of the neutral patches accurately enough, then we consider those values to be correct. Now, it's important to note that X-Rite on their website already say that the color checker SG chart may slightly vary in production. So therefore, they recommend photographers that need highest accuracy to measure the patches on individual charts themselves. But this does not make clear when does it become necessary to measure those patches yourself, and how does it relate to the fudgy and metamorphose levels, and what are the bottlenecks in this whole process. So let's go into that. Well, first, to finish the procedure, in step 4 of the camera profiling, the rest of the 140 patches are checked. And then finally, in the final step, we calculate the average and the maximum of the color differences for all those patches. And yeah, we can then compare it to the guidelines by comparing the data with the reference data. Now, I had already mentioned that we had already found issues, especially in the digital capturing of black areas in paintings. And therefore, we used an I1 Pro spectrophotometer of the Rijksmuseum to measure all the black patches of the color checker SG chart. To our surprise, we found lightness values of 11 to 12, much larger than the values of 8.05 that is mentioned in X-Rite's reference data. This means that if we would use the X-Rite reference data, we already would not meet the strictest metamorphose guidelines. This would be already the case, well, when working with a spectrophotometer. But if you use a camera, which is not a spectrophotometer, obviously, then when using this camera, the errors will be larger because, yeah, there are imperfections in lighting, spectrum of the lighting, camera optics, etc. For the fudgy guidelines, we may just stay within the strictest criteria if you use this spectrophotometer. But of course, when you use a camera in this way, then again, you will get the errors that I just mentioned. And that will also be very difficult to meet the criteria. So these results were quite concerning to us. So we repeated this exercise for all 140 patches of the chart. And the table on the left shows the color deviations that we found. So green colors refer to color deviations delta E 2000 that are smaller than 1. They should be fine according to these guidelines. But the yellow and the red parts, they refer to deviations that are larger than 2, and that is really not acceptable. And if you compare those green and yellow and red colors with the positions on that chart, then you clearly see that the black patches are the main bottleneck in meeting the criteria. So we investigated where these color deviations come from. After all, for the spectrophotometer measurements, we had used an I1 Pro instrument. It was not a brand new instrument, and it's also not one of those very expensive high-end spectrophotometers. So perhaps the color deviations for black colors were due to the instrument. So therefore, we also did the measurements with a high-end device. And for this, we took the Spectre2Guide instrument from B. Gardner, which is also a 45-0 instrument, so very similar optics as the I1 Pro. Now we created a relevant set of samples consisting of very dark, not to say pitch black samples, with different gloss levels, different glossiness, because somehow we thought that gloss could play a role in this whole problem. So we used the so-called NCS gloss scale, which consists of various blacks at 7 different gloss levels. And we also used a series of wall paint samples with very dark and slightly colored paints. And we used the Munsell grayscale, which has lightness steps from lightness from 5 to 95, with the darkest ones in a higher gloss level than all the other colors. So, and finally, we prepared a set of very black car refinishes paints with lightness values well below 5, because such paints can have very low lightness values. And for those samples, we also used gloss levels varying from very, very matte to very, very high gloss. And while keeping the 1.5 meter distance between ourselves, we managed to measure all of these samples with the 2 instruments. Now, what are the results of that? The graph on the left shows the lightness values of the two instruments plotted against each other. And it's clear that the I1 Pro instrument that is used in the Rijksmuseum actually does a good job. For these samples, it is well aligned with the Spectre 2 guide that is really a lot more expensive. We're talking about a factor of 8 to 10 times more expensive. In the graph on the right, I have plotted the lightness difference between the two instruments as a function of the glossiness of the sample. So this shows that the alignment is nearly perfect for almost all gloss levels. Only when the gloss gets below a certain threshold, which is about 20 gloss units, then the error in lightness reaches a value of approximately 1 unit in lightness. So both instruments actually are quite well aligned, and instrumental errors do not explain the much larger deviations that we have found before for black or very dark patches. So if it's not the instrument that causes these color deviations, then what about the color checker SG chart itself? Now, we checked with different charts produced between 2016 up to 2019, and all of them reproduced very similar color deviations. So the problem remained. It was not an issue of a chart becoming, say, dusty or color fading in the chart. So we turned to X-Rite and asked them, please check production data for these charts. And yeah, X-Rite confirmed that there had been no particular production deviations for these charts. And X-Rite also confirmed that the I1 Pro instrument of the Rijksmuseum should still align well with X-Rite's newer versions of this instrument, the I1 Pro 2 and now the I1 Pro 3. So all of this, nice results, but still we had no clue on the origin of the color deviations for the black patches. So we asked X-Rite also to send one of their original charts that they had used in 2014 to measure the reference data. So they sent us one of those charts, and we did our measurements with the I1 Pro and also with the high-end Spectre 2 Guide spectrophotometer. This time we did get lightness value of L equals 8. So finally we were able to reproduce the reference data. From this we concluded that the reference data is indeed correct for the original color checker SG chart from 2014. And we also conclude that the I1 Pro correctly reproduces that data. But we also conclude that the color deviations that we found before are due to variations in color, and maybe also to gloss, in the color checker SG charts that are produced after 2014. So let's have a slightly closer look at those measurement data. In the 2014 chart, the reflectance data for the black patches are about 0.6% lower than for the newer charts. This is the cause of the difference in lightness values that we have measured. We also measured the glossiness of these patches on the 2014 charts and also on the newer charts. And with the Spectre 2 Guide instrument, you can also measure gloss values. And then we found that on the 2014 chart, the black patches all had a glossiness that was 5 to 7 gloss units larger than for the other color patches. And this then caused these black patches to look so very black. In newer charts produced after 2014, the glossiness of the black patches has become lower, reaching the same degree of glossiness as the other color patches. But this has actually made the black patches slightly less black. So what are now the practical conclusions from all of this? Now we learned that even in laboratory conditions, it's very hard to meet the highest quality levels of the guidelines. It's even impossible, you could say, to meet them for metamorphose when using generic reference data. So that level definitely qualifies to follow X-Rite's recommendation to not use generic reference data, but to measure individual color checker SG charts and use that as custom reference data. We do not recommend using generic reference data and then manually tweaking the camera profile until you meet the criteria, because that is not only a very time-consuming process, but it will also actually make the camera profile less accurate, because you are optimizing towards a color target that differs from your own color checker SG chart, unless you have a really old color checker SG chart from 2014, of course. Now, we showed that this is well possible, this whole process, with an i1 Pro instrument. So there's no need to buy the most expensive high-end spectrophotometers for this particular goal. And we already saw that the black patches are the bottleneck, and our results are most relevant for digitization of artwork, where black areas play a large role, which happens to be the case for 17th century Dutch art, of course. So finally, we recommend to use camera profiling software that enables you to use custom reference data. For example, use basic color or focus. Thank you for your attention. Kira, you're still there?
Yeah, I'm still there. Hiya. Henny, Carola, who's next?
I'm next.
Okay, would you mind sharing?
Yeah, I share screen with you all. I'm Carola. So, oh.
Yeah, perfect. That works just fine.
Okay. Well, in follow-up of the presentation of Erik, I want to show here two things. One is using your own lookup table in Focus, the camera software of Hasselblad. And the second part is how to make a profile when you're making tiles of a painting of, for example, more than 5,000 PPI. Okay, use your own lookup table. Here in Focus, yeah, you shoot your targets at the good exposure and neutralize it. And here on the right side, at the top reproduction, you have color calibration. You can say edit. Here's a plus. Now you can enter your targets. And here I want to upload my own lookup table. So I say top, and here is my lookup table. Open, and it's in. And I can calibrate. Oh, shit. Where is it? Oh, here. Oh. There it is. This one, it's Focus wanted that you use a by top divided text file. It looks like this. So this comes out of the i1 Pro. In this case, it was an i1 Pro 3 with D50 and 2 degrees. And here you get the measurements of your target. And you can say calibrate and create, done. And then on your color calibration, you can enter the profile you made today. And in our case, we check here the central neutrals. We check with your lookup table. And that's what you can do at the curve. Here you have an RGB, but there is also new in Focus, the Luma curve. And that's a slightly better one. At least we tested it, and for us it looked better. So here you can make sure that the central neutrals are correctly. So when you're done, you can export it, and this time you exported this as in our case, we work in ACE RGB v2, so we exported this like this. And then you're done, and then you can evaluate the performance of your capture. We made, we have now a new tool. It's called the Rijksmuseum Image Performance Tool. It's made by Henny. He will show you later how that works. The next part I'm going to show you now is how to make a color profile when you are shooting tiles of, for example, 5,000 ppi. We found out that if you are so close by, you better make a new profile. So shoot also your target that close. So in this case, it looks like this. So we're not only shooting the night watch at this high resolution, but also a lot of other paintings like the Vermeer, for example. And we used the moving easel we have and a studio stand. So not the fancy beam system of the night watch, but the moving easel. So you shoot your targets in the same resolution as finally you want to shoot your painting. Make sure the lighting is correct, at the right exposure, you neutralize it, you shoot the whole target like this, then you export it. You have set your settings all at factory. I don't know if yeah, they are here on the right side. You can see at the top reproduction. You see working spaces, Hasselblad, L-star. You set everything on factory, and you export your files. Here you can see the output profile has to be on source. Okay. So when you have exported, you load in everything in Photoshop. All the tiles, and then you stitch them manually without any blending. So you don't use photo merge because Photoshop make use of all kinds of tricks, but you stitch it manually, and you keep the profile on Hasselblad L-star. You see, I had it somewhere on my desktop, but I presume you believe me that stitched small. Oh yeah, you see here. Use the embedded is the Hasselblad L-star. So this is how it looks. But then there is another problem, because in Focus you can't make your profile. So our colleague Rob Eurtman came up with a solution, and he said you had better use then Argyle, and that's a command line software. So that was another issue. You had to not to learn Argyle. I just make it a kind of simple for myself. This is how it works. Here at the bottom, you see this is this computer I work on, and this is the folder I put files in. And I have the commands ready for me. I made a green every time, every time changes. And you have two commands. One is called scan in, and the other one is called call prof. And you have to make sure that in the folder of the subfolder, this is provided by Argyle. This is the color checker. In this case, it's still the the lookup table provided by Xwrite. I didn't change. It is possible to use your own lookup table, but we are not that far yet. And this is another file provided by Argyle's you need for the command scan-in. And this is the target in Hasselblad L* RGB. Okay, so here's command scan-in. And okay, Argyle, you see here in the folder, puts two other files in it, which you need to get yourself an ICC profile. So here's the next command. It's called callprof. And here it goes. Okay, and then you can see here in your folder, you have your ICC profile, which you of course can use. I go to the first one again, which you can use in focus on the raw image. So here you have the input profile, and you can say, it was already there. Normally you have to, when it's new, you have to put it in the library, but it was already there. So now I can, what you see now, it changed in yellow, but don't worry, that's a bug in focus. It's not really went yellow. So that's, you have to apply this profile, of course, on all the tiles of the target. Then again, you export all your tiles, and this time not as for calibration, but in the profile. You work yourself. So it's, in our case, we work in ACE RGB v2. You export all the tiles, and again in Photoshop, manually stitching, and then you can check whether your profile is correct. If it's correct, you go to the painting you made, the captures of the painting you made. In this case, it's The Milkmaid by Vermeer. Oh, I have also one. No, it must be here. Okay. No. And you can see here, it's if you zoom in at 100%, this is how the painting looks, and you can provide it. Yeah, here's the input profile called small, and it's in it. This is what I wanted to say. In 2015, Henny and I made a manual of photographing two-dimensional objects. It was published during the conference here in Amsterdam. At the moment, we are very busy updating the manual. So we are intending to put this, and also what Henny is going to tell about the Rijksmuseum tool is also going to be in it. So thank you very much for your attention.
Thank you, Carola. That was brilliant. Thank you very much. And I guess then in that case, Henny, if you want to go ahead and share your screen.
Yes. Yes.
Yeah, great, that's working.
Okay, thank you. My name is Henny van Beek. I'm one of the staff photographers at the Rijksmuseum, as you already heard, I suppose. So now we know how we can make a camera profile and how to implement it to the capture. And the final step is now to check all the values, and I made a tool to do so. So I would like to present the Rijksmuseum Image Performance tool. This is a calculation tool. It's made in Excel, and it evaluates captures with a digital color checker SG in it. I developed the Rijksmuseum Image Performance tool because we could not find suitable software that allowed us to use different lookup tables for the digital color checker in a simple way. So this tool indicates the quality of at a glance, and if you need deeper insights, that's also possible. Here you see the overview page or tab of the tool. And there is also a fill-in tab, which is this one. And there is also a detailed tab, which gives more deeper information about what you've seen in the overview tab. Let's start with the second table. That's this one. It's the results of the Delta E 2000 measurements. You can see immediately on the colors if FACI, the strictest guidelines of FACI approve on this tab or on these items, and I'll walk through. I'll show you the detailed issues or things you can measure. At first, we measure the specular component of the blacks, and that's a bit under construction, but it works already. Then we measure the flat field calibration. We also measure the exposure, the delta E mean and delta E maximum, delta E of the neutrals, which is important as indicates the color cast. And as you can see here, it's red. And we also measure the delta L maximum of the neutrals in the center, which is also known as the OECF. You can also see at the left over here a chart of the OECF. The maximum and minimum is plus and minus 2. And as you can see here, it stays within the boundaries so it stays within the tolerances. What we also measure is the highlight gain. And here below you can see the gain of everything. But for Metamorphose and FACI, the highlight is the most important gain part. And you can see that over here. And you can see the outcome over here. Well, now since we had a red patch, we might want to look what's the problem with this capture. And we can go into detail. These are all the delta E's from the chart compared to the lookup table we inserted. I will come back to that later. But what you also can see is that the 290, which is red, is only one patch, which is the black patch. It's this patch, to be precise. And the rest is all fine. So, the light turns off here. There's some kind of problem, but I hope you can still see me. So the patches, okay, turns on. I'm a bit confused now, but you see that the problem isn't that big. That's what I wanted to say. Metamorphose only takes care about the neutrals, which I gave a thicker line in this overview. And well, now you have a better insight in where the problem lies, and you might think about that, what you want to do with that. In the left table, that's over here, you see the same thing actually for delta E 1976. And you can see that everything is green here. And so the color cast is not a problem over here. And that's due to the fact that we measured in the Facci part, or the delta E 2000, if you like. We also examined the edge, the neutrals at the edge of the chart. And we didn't do that, or I didn't do that for the neutral. I did for the 1976, I only examined the central neutrals. So as we already saw, the problem lies in the edge of the chart. So the neutrals in the center are okay. That brings me to the second part of my presentation. And that's how do you get your information in your Excel sheet. Here's a fill-in sheet. Here you fill in your lookup table. You do that by actually the same way as Carola explained already. You make a text file from your measured values, and then you can import it here. I'll do the same for the harvesting of the numbers from the capture, which is a bit more precise, I think, or a bit more interesting. Okay, what you need is you import your capture in my case, what I do, there might be more possibilities to do this, and I'm actually waiting for someone who helps me with this. But the way it goes now for me is you import it in delta E, which is software provided by, or is a free web-based software from Pictoray. Most of you will know this. And you import it, and you don't look, or you don't, it doesn't matter what the outcome is here, because it's not the same as the outcome in your software will be. But here you have the CSV file you can download. So if you download this one, what you can do, I'll go back to my performance tool. You make a new tab. You say in archive import a CSV file, import. Okay, let's get the information. Next one, you divide it by commas. Next one. Okay. This is RGB and LAB numbers. You highlight the LAB numbers. What I see is there are dots instead of commas. We need commas. So what I do is I say find all the dots and replace them by commas. I say change everything, okay, quit, And now I have a list of comma divided numbers, and I copy them and paste them inside here. And then we should have another, you saw everything changes. And now for instance, if we look at the OACF, you see that the blacks, E6, is underexposed, rather underexposed, but still okay within the limitations of the guidelines. And for the rest, everything is quite reasonable. You still see a color cast here. We can check it. And what we see now is that the problem at the first chart was over here. Now it's over here. So everything changes, but still there is a small problem with the emphasis on small, but because I think it's not a big problem. Okay, I want to finish my presentation with this, and thank you all for your attention. Thank you.
Thank you very much. That was really interesting. I think we already have one question from Tony, but I'll give the audience a few minutes to have a think what kind of questions they might want to ask. Yeah, like I said, feel free to either put them in the Q&A panel or the chat panel, which you will find at the bottom of your application. So if you've got any questions for Carola, Eric, or Henny, then please feel free to put them in the chat. Henny, Carola, Eric, if I could ask you to unmute, and then we'll be able to kind of bounce questions around. Perfect. So while we wait for a little bit, I've got a question for Eric. I was quite interested to hear that you checked the X-Rite color checkers, and then it turned out the 2014 one was the one that they're still going with, even though they have obviously since produced a lot of new ones which have this discrepancy. But they seem to be quite responsive to your questions of, oh, what's happening, and we're not quite understanding what we're seeing. I was wondering if there's also been a feedback in the different directions, so X-Rite are taking on some of your feedback and maybe publishing that now is a kind of like up-to-date guide to their new X-Rite checkers.
Yeah, we did update them on this. We did not really get feedback about what they will do with it. I can imagine it is also, this is really, if you have the very tightest tolerances, this is something that takes place. I guess the majority of their customers will be, well, other types of photographers where this may not be that much of an issue. So yeah, I don't know what their business case is to really do something with it.
Okay, yeah, no, I just thought, because I'm sure this is of interest to a lot of photographers, and that was quite a discrepancy that you measured. So I was just interested what their reaction was. And then, yeah, we had a question from Tony Harris, and he asked that during Henny's presentation. So Henny, I'll ask you first, and then obviously if Eric and Carola have something to say about this. So Tony says, specular component of black, is that measuring glossiness of the black patches?
Yes, it is. Yeah, it's often referred to as specular component, but it's measuring the glossiness. I don't measure it in a way, for instance, Eric measures it, but I compare the more center black to the blacks in the edge, on the edge. And if the light reflects differently on the outlines, as it does in the middle, there is a problem with glossiness. So it's not that I measure the amount, but I measure there being a difference.
Okay, thank you. Tony, does that answer your question? We'll move on to the next one, and then yes, it does. Okay, wonderful. And then Andrew Bruce is asking kind of to all panelists, to all three of you, do you think a target with darker blacks would make more accurate profiles or increase the possibility of error?
Yeah, maybe I can start. I don't know if Henny and Carola want to jump in as well, but I do think it is thinkable to make darker blacks indeed, and that would make yeah, some of the actual objects where this takes place would become more accurate indeed. So yeah, there are certainly applications where this would help. Yeah.
And
Yeah.
we are still experimenting with that. Erik has provided or is going to provide us with more black patches and more glossy and non-glossy patches. So we are still working on that actually.
Okay, great. And then another question from Tony Harris. Are the NCS black tiles traceable to NIST or NPL? Did you take into account instrument error such as warm-up issues? NPL suggests a 30-minute instrument warm-up time.
Yeah, we do take those measures into account. I think the NCS gloss scale, if it's really traceable to NIST or NPL, I don't think so. Actually, it's a commercial product. We used it to to find out about what are the accuracies for different instruments. So they are not used, say, to calibrate instruments, for example. These were just targets to find out what are the instrumental errors. So therefore, these samples could be used for that.
Oh, thank you. There's another one from Anna Arca. Are you applying these calculation systems to images produced with cross-polarization?
That's for Henny.
Yeah, everything like the paintings we photographed with cross-polarization.
Yeah.
So like
so you are applying it
like
to
the tiles of the Vermeer I showed, it was cross-polarized.
Yeah.
Okay.
And yeah, what we actually maybe we are not totally sure about that, but we have a hunch that it is. We bought a new i1 Pro 3, which is also has the possibility to measure polarized light. But we think actually that our aim is to look at a target as a spectacle would look to it, which is non-polarized, of course. But we use polarized cross-polarization for our captures. So we bring it back to the normal measured targets. So we lower the contrast, in fact. Okay,
thank you. I can't see any more questions. I had one for Carola. You know how when you applied the profile and then you said the yellow hue was due to a bug in focus. How did you figure out that was a bug in focus and not you having done the calibration wrong?
So when you export the files and you open it in Photoshop, it looks good. And actually, when you go in focus and you measure the white, it's white, and the gray is gray. So, but it was not only now; it was already kind of known. But we always thought, yeah, that's weird. But yeah.
Yeah, so it was a fairly straightforward one of just kind of sanity testing your calibration, being like, no, this must be focus. It can't be anything.
Yeah, normally we don't see it because we use the raw profiling of focus itself. But now you import an ICC profile and then it happens.
Right. Okay, that's probably a lesson for everyone not to go with what their eyes are seeing, but actually look at good measurements. Okay, thank you very much. Are there any more questions from the audience? Anyone else has a question? I don't believe so. So in that case, that leaves me with thanking the three of you. Thank you so much. That was really, really interesting. And I think so we are recording this, and so I think there was so much information in there. It might be worth rewatching this several times. And really kind of understanding the process that you guys have been investigating and presenting to us. So yeah, thank you very much. That was
yeah, thank you very much.
Thank you.
Thank you.
Okay, so in that case, that only leaves me to announce that obviously we have one more session next week. That's a really packed session for various reasons. We've got a lot of speakers in there, so it might overrun a little bit. But obviously, if you have to leave, if you have to go to work, then we are recording it, so you can always find that on our website. And ahfap.org/conferences. So that's where we're putting the videos. Give us a few days. We're not able to upload them straight away after we finish recording, but they will end up on that website in just a couple of days after our online events. And I believe that is all I needed to say. So yeah, thank you very much for joining, and hopefully I'll see you all next week.